Welcome to today's Snack and Learn webinar with WSP Global. This topic is advancing digital project delivery with digital twins for transportation infrastructure. We're going to provide a high-level overview of digital twins. Myself, I'm Tom Coleman, and our speakers, Bulent Caracas and Carolyn Bean-Hodges, will also be joining them. They'll introduce themselves shortly. We will define basically what WSP Digital is, look at some technologies and best practice. We will relate this to the United Nations Sustainability Development Goals, then also look at how human-centered artificial intelligence can enhance digital twins for cities and regions. And then we'll have time for questions and answers. Myself, I'm Tom Coleman. I'm Vice President and Director of WSP USA's Visualization and Data Intelligence Group with WSP USA, but we help project teams with all sectors across the company in terms of advancing tools and technologies for projects and programs to serve our customers and clients. And I'd like to introduce Bulent.
Hello, I'm Bulent Caracas. My background is structural engineering. My current role includes design automation with developing custom applications, 3D modeling of complex bridges, digital twins, data analytics, and business intelligence.
And Caroline?
Hi, everyone. My name's Caroline. I sit with Tom in the Visualization and Data Intelligence team. My background is in developing all different manners of digital twins from kind of concept, and design through to implementation and maintenance. And my role on that is really focused on the end users and understanding the kind of user experience that requires. Thanks, Tom.
Yep, thank you. Again, if we look at the evolution of technology over myself, I've been with WSP for nearly 20 years and seen the whole transformation of how technology within our company has advanced. From 2D desktop applications to the cloud to mobile to now insights with digital twins. And really the power of digital twins is bringing, again, all the data of the past with the opportunities with cloud infrastructure today with business intelligence, cloud computing, and IoT. But this is what is creating the opportunity for our industry to create digital twins. Our journey in this started about 10 years ago when we actually developed I have to turn off the pointer. When we developed a virtual model for the city of Chicago. And why isn't this video playing? There we go. But at this time, we built a large regional scale model of Chicago with all the buildings using LiDAR data and other tools. But really the question was, how do we embed data into models such as this? If we can build regional or large scale city models, how can we embed data or other technologies within these models? And really the opportunity for that is coming, as I said, as we move from 2D and be able to develop these 3D models, but to advance that into real-time data and information for cities, where we can take the infrastructure, the streets, the vehicles, the street lights, the buildings, and use data from those structures or operational structures or systems and start to build the connectors and the IoT and everything that will give us a real-time vision of creating an operational model for a city. And I think that's really the power of a digital twin, not just for infrastructure, but how we can create these systems of connected data. And to do this, there are a number of challenges we need to address in our industry as our infrastructure becomes more complex in the concept, design, operation, and construction, dealing with workforce strategies all through the design process. How do we automate? How do we deal with environmental impacts? How do we use these tools to create predictive decisions to support these assets? And in this representative picture, whether that's an airport, a highway, a rail line, or buildings, or other physical infrastructure. And this value chain is really a lifelong proposition for our projects, because it is about continuous optimization and learning. This is a cyclical process of being able to build the data connectors and information that allow us to move from conceptual design into a virtual TIM, meet different requirements and insurance, and to be able to build an operational model that could give us the power of artificial intelligence and simulation in order to understand how to construct, maintain, and operate infrastructure well before a shovel goes into the ground. And really that is the value statement that we can present to our projects and clients right now in order to understand the impact or management of large-scale programs. With this, we have to have an end in mind in terms of the assets, and many on the call, you may be familiar. Of course, all our infrastructure eventually ends up as an as-built, and that as-built becomes the basis of an asset or operational system for the maintenance and operation of those. Really, in a digital twin, we're bringing these assets forward. And not to get too in-depth in terms of how we do it, but if we use 3D design software, and we'll show you, we can embed that software with information that helps inform the assets and carry it through the life cycle. There are a number of use cases for digital twins. What we'll show you, obviously what I showed you with the Chicago model, visualization, but moving forward from visualization to be able to manage data and information, to provide reporting, the incorporation of reality data. In the pictures on the right, that is a point cloud reality data around those bridge structures, and if I toggle that off, we start to see the actual BIM information or model data that information. We can do class detection with the utilities. We can begin to think about asset management really in the beginning of a project instead of the project. And then we can automate digitally tendering and contracting and use these tools for many things. We're proud to announce that actually recently we won Bentley's Infrastructure of the Year Award for going digital for our work across the country and developing digital twin solutions. And I'd like to turn it over to Bjorn.
We developed some Python libraries for data extraction and pay item mapping and carbon calculations. We use Power BI, as you see on the screen, as a presentation and sharing tool. In this example, you see a very detailed cost estimation at an early stage of the design, including cost, quantity, dimensions, and elevations of some of the bridge components. And the nice thing about this workflow is it's automatically update itself when the design file changes. It saves significant amount of time and eliminates human errors. So in that example, we integrated the EC3 database in our tool to get EPDs and do some carbon calculations. So we are doing, we are getting EPDs from EC3 database and quantities from iTwin and do A1 to A3 calculation. For A4 plant to construction site transportation, we extract plant latitudes and longitudes from EC3 database, and we used an open source routing engine to calculate distance, then the carbon amount due to material transportation from plant to construction site. We also calculate construction activities related carbon amount based on estimated construction cost. So you can click different bridge components and see their quantities and embodied carbon amount. Yeah, similar cost estimation dashboard for a building. This model was created by Revit, and you can click different components on either visual, or you can use slicers to look at different materials and cost of this building components. Like you can select doors, it shows all the doors, you can see the quantity of doors. I mean, just cost is just a placeholder, it's not accurate, you just put something to show cost. But we have a cost database, so you can update cost database and get the desired results. And this is another tool that we use for bridge design. OpenBrim is a cloud-based information modeling platform that offers parametric bridge design, integrating 3D modeling, APA. It has its own cloud-based solver, but if users prefer to use desktop bridge design applications that they are familiar with, such as Larsa, CSI Bridge, or Midas, they can export the APA model to these programs with their native file format, not only the stick model, but the boundary conditions, loads, and even construction staging data. And producing 2D CAD deliverables in DGN, DWG, or DXF formats, and it can also do, AASHTO code check and load ratings. And since all components are tied to each other, if we change the 3D model with using one of the parameters, all the other components are updated, including 2D deliverables and APA model. Yeah, as you see at the right-hand side, it automatically updated all the exported design files. Yeah, of course, we can export this IFC and open it in preferred CAD application. Yeah, this
well, thank you.
Yeah, back to Tom.
Another aspect of digital twins is integrating live data and information into our models. In this case, sensors. We can hypothetically model sensor activity, but we can also install sensors on infrastructure in the design phase on an existing structure or bridge in order to do health monitoring or analyze the different aspects of movement of a bridge or change or detection. Again, a lot of times this type of activity was done in a silo itself, but now we can integrate this into our iTwin platform, our digital twin platforms, to have real-time data and information to aid design and problem solving solutions during that design, well before construction, using data. Now I'd like to turn it over to Carolyn.
And this is another method of bringing in real-time data and alignment with our design. So here you can see quite a nifty example. On the right-hand side, we have the proposed design, and then in the center, we have our GIS data, any photo or video capture as well. So users are able to pan around from one place and understand the current state and the proposed future state. And on the very left-hand side as well, they can kind of locate themselves within a broader map.
Thank you. If we want to extend this thinking, really it's how do we apply a digital twin upon a city or region? As many of us are aware, many of our communities and areas around the world, data is already unified. Whoops, go back. Data is already unified in let me get my pointer here. Data is already unified with 2D GIS and information. we want to turn that into 4D dynamic information, as Carolyn showed in the previous slide. And then previously, as we saw, how we can embed sensors or real-time information, not just on structures and bridges, but on buildings, highways, airports, or what have you, starts to build the real-time information and data of a digital twin. The extra layer to that is how do we actually transform how we traditionally looked at social and economic indicators and data and essentially people, how we use human-centered artificial intelligence and simulation to better understand mobility and jobs and economic development and places and all the different factors that make up the life of a city or a region. And then transforming how we can envision both buildings and infrastructure to create real-time data and monitoring systems that enable us to understand the impact of infrastructure well before it's constructed and be able to model that and understand it through the process of planning, construction, then operations, with the goal of essentially extending the life cycle of our built environment. To do this, we are working with partners around the world to be able to take reality meshes of cities in order to take high resolution data. This is generally done best by helicopter for greatest idea, but we can scan cities or scan areas, create point clouds, and put these within the design tools, in this case, Bentley iTwins, to do this, to better understand our projects and the impact they have to our cities and environment around them. And this is an example here again of let me get to take my pointer. But this is a point cloud of San Francisco, actually, that Aerometrics did for the city of Cal. This started off as a point cloud and then was enhanced through Unity or through Unreal to be able to create a dynamic simulation. The point is, behind these data, behind these buildings and pictures, is that point cloud in data. We can attach a data schema to those things. We can start to turn this into an operational design model. It's not just a picture or a visualization that I showed you earlier with the Chicago model, but actually how we're using this data now to achieve that end to data enrich models. And Carolyn?
Yeah, and I think you already touched on, Tom, when we actually look at the digital twin of a city, what drives that city is the people within it. So that allows us to bring in another technology layer that represents the individuals or demographics in place and then plan accordingly or understands how our design works. A lot of cities, countries, regions have publicly available data that is, anonymized groups that can reflect who lives in that city and what their needs are. And then if we move to the next slide, what that drives us is identifying the use cases that matter to that area and to that population and how we can predict that our design will interact and support the population in place. So it's able to meet, test and validate quite complex scenarios ahead of time. And next slide, please, Tom. And then another context when we consider the people who are going to be living within our designs and as-built is the UN Sustainable Development Goals, all of which kind of impact our projects, but in particular looking at goal number 11, so understanding how we can enhance our sustainable cities and communities. And one of the ways we can do that, of course, is understanding the environmental impact of our project. So when we move to the next slide again, thanks, Tom. Bullen's already touched on the power of our digital twins to allow us to extract and calculate the embodied carbon within that design. To pull this out at a more granular level, another tool we have in our toolbox is through partnership with Microsoft, the Cloud for Sustainability Manager, which is a platform for unifying data. So this enables us to take a cradle-to-gate approach in bringing in predicted embodied footprint of the design itself through to construction activities, electricity and water in construction, and then during the remainder of the life cycle of the asset, we might be looking at vehicles travelling, through a tunnel or site offices, and really getting that comprehensive overview of predicted GHG emissions or water usage, and also how we can reduce those emissions. So if we move on to the next slide again, we've just got some examples again of that unified reporting, which our clients care about, we care about, and any stakeholders care about, from a quite high level through to really granular approach, and that magnifies the power of what we start with a digital twin. Thanks, Tom.
And so that concludes our presentation today, but really through our development of digital twins and implementations of digital twins globally, this is not just a single application in itself. Every application is comprised of people, processes, and technologies. Many technologies are available to support digital twins. We've only showed a few of those today, but again, the movement is towards an open source framework that allows us to build the connectors or the pathways between these tools to better enrich and develop dashboards. And whereas BIM was not a really operational tool, but an information management tool for design, digital twins adds the value on top of that to turn BIM models into operational models and be able to incorporate artificial intelligence and simulation. And this is an evolutionary step for the AEC industry in general, but also for WSP global teams across sectors within the company and geographies. So again, thank you. And we'd like to open it up to questions. And we had a couple of questions actually prior to the webinar. A typical client perceives digital and infrastructure as additional cost, low return. How do you quantify it? How do you sell that service? Well, I think at a high level, we may have answered that question, but that is a reaction we get every day from our projects and client teams. Why do this when what we've done has worked so well for decades, that is producing plans to implement infrastructure? And again, I think you have to look at what the cloud offers to our industry now, and the ability to manage more information at less cost and in faster time. And then another question, has the digital twin concept extended to traffic management and communications technology? Yes, and again, because of the limit of our webinar, we are working with many different partners such as Iteris and HERE that are also, for example, HERE is the largest provider of mobile mapping of roads and highway networks across the world. HERE has their own digital twin of the world and data connected to that model. That data we're working with Bentley and HERE to directly consume that data in our design processes now. So again, the opportunity that the cloud and different data systems and cloud data systems that we can begin to tie and bring this all together into a solution. And I think, do we have, if there's another questions here? Actually, I don't think I ever showed my camera. There we go.
I think on the traffic modeling question too, something we often see is, what do you mean by digital twin, or what is a digital twin? And it doesn't have to be an as-built or collection of assets. It's really around that, using data to represent a place or an activity or a thing. So it very much applies in the transportation realm as well. understanding what's currently there and how we can also identify, test and validate future activity.
Yep, and another question here, how are you looking to manage scalability across it? What standard data schemes have you adopted? Well, the dominant standardized data scheme is of course promoted by Building Smart in terms of IFC, which is essentially interchange file exchange format. But what's behind that is ISO 19650, which is a global standard for how you deal with 3D design and what you need to be able to develop a common language. And really it's that common language as part of IFC that allows us to understand a bridge in one geography is also a bridge in another geography, and the parts and components are similar. And I think, Beelan, you're doing a lot of work in this area if you want to expand. You're on mute.
Sorry, I was mute. So yeah, we are using IFCs for actually we are getting IFC and we are inserting additional data based on project needs. Then we can push it back to iTwins, so we can let's say so we need to insert embodied carbon amount to an IFC. We can create custom property sets, and we can calculate that, put that in, and push it back to iTwins.
And then how to decide the frequency and update a point cloud of cities. It's quite a real effort. Yes, it could be, but it's part of this standardization or common knowledge base. And there's many of the utility companies are trying to do the same. So again, it's not about just one entity or partner in the industry. It's working groups or partnerships across the board to help build this language of understanding and understanding.
Next question, Tom, maybe we can give our cost estimation approach. So yep. We did a parallel practice for a cost estimating. So it was a very huge project, including 60+ bridges. And it took 6 months working 2 engineers to create cost estimation of this project. And of course, we developed some algorithms and scripts, but runtime was just 6 minutes to extract quantity from 60 bridges, roadways, etc. And
from models.
Yeah, from the models. And if someone changes the model in file, we can rerun it and we can get the latest version of the cost estimation.
And then what are the challenges you face in implementing a digital twin? Well, really, I think the challenges aren't necessarily the technology now, it's people. It's building the capability and assurance and cooperation among many different groups of people to be able to understand that the technology can aid us, and the small investment in the technology can have wide-ranging impact in how we understand and model and look at information and data. Carolyn, your experience in Australia actually probably hits on this.
Yeah, I think so. And I think any digital twin too, at the end of the day, it is a tool. So part of the journey, particularly at this stage in the industry, that you're going on is understanding how the tool can benefit that project. So what that tool looks like, as you've said, Tom, we've shown a couple of options today, right, on how to implement a digital twin, but there's a world of choices out there that we can provide. So understanding who your client is, what the scope is, who your teams are, to find the right tool for them, and then also how it fits within their workflows is really important to make sure that it's appropriate for their uses.
And I will also add, and is the partner that we mentioned, how we're using helicopters. Right now, they're undertaking a program with the national government in Australia to use point cloud mapping of the whole continent of Australia to create an operational digital twin of the whole continent. And it's not because you can't do it. The technology is there. The processes are there to manage big data now and to provide insights. So the process of being able to use unmanned or manned aircraft to scan, create those point clouds, and then put it in data models and systems, it is going on in projects around the world. Singapore has a national digital twin. The UK has a national digital twin policy for infrastructure, all the infrastructure to go within a digital twin. Again, how do you see digital twins assisting a digital handover between design, construction, as built? Is the industry there yet? And part of that, this is quickly evolving because in the United States, there's through different federal research programs, there's partnerships and research programs between over 18 DOTs now to advance BIM standards, which includes digital signatures and tracking of design drawings and being able to enable the transfer of a digital model versus a paper plan set through the process. And then the question is, are our tools from the design industry, whether Bentley, Autodesk, Esri, do they support the delivery of models with digital signature and security and other things as we did traditionally through our processes? These tools are quickly evolving. I think the general impression, because of the cost efficiencies and the scale of economies that are attainable now, this will quickly become the norm. And then, which issue are you proud to solve with a digital twin or never could predict? I think really that is again, the synthetic modeling of populations. Now, within our industry, we've done transportation modeling, or transportation behavior has been a science for many years. How we could use census data or information to determine how people use, how they move about. But we're now can extend that two steps further, where we can develop a synthetic population models and then use artificial intelligence, attach data to them. These models begin to solve problems. And our partner, RWI Synthetics, is doing this with the National Energy Lab in the United States, with projects in Los Angeles and Nashville, where they're untapping hidden things in data, such as being able to simulate and explore when people don't have access to energy and heat, and what is the impact of that, or what is the impact of education attainment in decision making and other things, or homelessness, or other factors that we really traditionally could not understand easily in transportation modeling, that now we can understand in a digital twin or synthetic modeling process.
I think also it's easy to underestimate how powerful it is to break down those silos, design and information silos at an early stage. I think the other day I had someone say to me, a structural engineer quite early in design, they had to slightly step outside the right of way for a design due to different factors on that project. And they said, that would have taken me days previously to try and explain to the client, and really tough going and hard work. But it was a 5-minute conversation that I could use with a digital twin to show the design, show the impact to the area. They got it done and dusted. It's quite powerful at that level as well. Yeah.
And I think another comment here is specifically to cultural resources, which could be affected for large. And Carolyn, of course, you're running into this also.
Yeah, absolutely. So it sounds like this question asker Yes, at the moment with GIS, you can kind of see the lay of the land, right, that's going to be impacted. And then what we're seeing now with digital twins is we can bring in a very accurate and early on version of the infrastructure that's going to be built in alignment with the GIS data, maybe photos or videos, so that you can walk around that area and kind of see the design in place. So whether that's going on to a house or very specific landmark, or down by a river and getting a view of the future. You know, it's almost like putting on your augmented reality goggles and being walk around and understand the impact and have photos and videos of that on the spot to compare. The other element I'd say as well in terms of a digital twin is land use planning using data sets. So there are also other digital twins that look at modeling scenarios based on factors such as, you know, location to public transport or, you know, walking distance to green spaces. So you can really, from that environmental or, you know, cultural resources perspective, bring in lots of data layers to evaluate and predict different options quite early in the project.
And part of this perspective, again, we're learning how to use data that has always existed in new ways, and predominantly GIS data, which has been around for many years. But that data was perhaps siloed by GIS professionals, planners, or others in the field. But now we can attach 3D data to that GIS data and build a more informative picture and catalog. That many cases in the country, historic buildings are mapped, they're known, those locations are known. But now we can bring the photos, we can use tools like Cubics to scan the interior of those buildings or the exterior and put those all in one model in one place in one dashboard, so you can view and analyze that data at once instead of 4 different softwares. That is the power of a digital twin, is to be able to align all that historical data, all that knowledge about our cities and places, and augment it with new tools like 3D and put it all together and make it actionable. And the question here, do we see the great benefits for smaller projects and large scale projects? And the answer is yes, because at smaller scales, as Carolyn showed, we can use an off-the-shelf, you can buy it on Amazon.com, a camera, a 3D camera. And you don't need a survey or control or anything, because there are spatial models. Our industry, the partners behind us, have developed the spatial models, just like Google Earth has evolved. Google Earth has evolved. So now we know how to handle spatial data, whether it's drone data, LiDAR data, mobile mapping, camera data. We can start to align those things. And so that can be done, I think, at any scale of a project, because the cost of the actual data acquisition device, in this case, camera, that cost has gone down extremely low. And and also partners like Esri are enhancing that capability within the tools. And I think, is there some other questions here? Let's see. Are you able to support planning team along the process using based on IS embodied carbon optimized measures? Or is this something to calculate first when a project is finished? Well, again, as Bulent showed, Bulent, everything that you showed isn't built yet.
Yeah, it's not even 30% design. We just started from the very early stage of design, and we are providing data to design team and get feedback. Then it's kind of, you know, a cycle. So yeah, we are able to do that.
Yeah, and I think that is what's really changing having worked in small projects, large projects, or whatever. You always have the problem of every discipline doing what they know how to do best in their own silo. by using visualization and models, you're able to bridge those silos metaphorically and start to build use cases. And in some of our projects, our environmental teams are using the digital twin model to look at view sheds of a proposed project. And you can't do that in real life in the field because it isn't there yet. But now you can bring that model into the context reality and say, well, if you build it, it's going to impact different environmental effects such as access, view sheds, or change mobility patterns or other things, or create noise or unwanted pollution or what have you. And then, do you see digital twin model used in water modeling in the future? And I guess, but I don't want to, I think we all could probably add to this, but again, just the issue of sea level rise. In many of our communities, we've been asked by our teams across WSP, actually, can we simulate and measure and predict and analyze sea level change for the impact of our environment? And the answer is yes. Where this was traditionally done in 2D and GIS or other planning tools, we can now build synthetic models or realistic models of communities, whether on the physical side or the human side, and start to look at a change in sea level and how that might interact. One of these things, a problem that was recently presented to us was the nature of how runoff is calculated in our urban areas is dramatically being changed because of this understanding. And really that's because it is no longer terrain that determines where water will go. It is the built infrastructure. It is the sewer lines under the streets when they overflow. All those grates, they can become point sources. And then the street becomes a new channel for the conveyance of water. And where we understood that was naturally driven by topography, we now have to understand our physical infrastructure drives that in order to be able to answer those questions. And then I guess that is the end of our questions. And I think we have about 15 minutes here, but I guess, Bjorn, from your work over the past couple of years, what have you seen the dominant change in your area in terms of software and capabilities?
So yeah, digital twins definitely helping a lot for reducing time, eliminating human errors, and getting results faster. And we can look at different options, different alternatives. With the traditional way, you have to spend time to come up with different options, look at different options. But parametric approach.
I think did Bjorn's camera freeze?
I think
Carolyn,
so.
I think you can follow the question.
One of the major things I think we've seen in the past 5 years is 5 years ago, something like the IoT sensor application you showed, that had to be completely custom built. You know, you had to work with acoustic engineers, software engineers, a whole body of people to set up that data stream. Now, a lot of these things are off the shelf, or, 50, 70, 80% off the shelf. And it's about applying it and configuring it for your project. And that makes it much more accessible, I think, to our clients and to different scales of projects as well. So it's moving fast, and we're figuring out the standards and processes that need to support that at the same time.
Yep, and of course, Bjorn, who's having to log in, Bjorn's background is a structural engineer, but he's also a self-taught software programmer, and he's a very unique skill set. But in myself, I'm an urban planner and transportation planner. Carolyn, if you can describe your background a little bit.
Yeah, started in a psychology background and then moved into software development and then digital twin solutions. So I like to think that we can cover many different, sides of the triangle.
Yeah, the point is that we now have, because of these tools, we're able to bring disciplines across the company together within common platforms and decision making. And I guess we have about 7 or 8 minutes left. If there are any other questions from, very exciting, we peaked at about, I think about 78 users, 78 call-ins, and and then we still have a large, so if there are any remaining questions that we can help you with from the audience, feel free to add those. The PDF is in the handout section. Our contact information is in there, but we'd like to thank you for your time and allowing us to present this high-level overview of digital delivery.